So just to recall, we defined the complex exponential e to the x plus iy as the real e to the x times e to the iy, which was cosine y plus I times sine of y. And cosine and sine are periodic, and that's why we have repetition. So recall when we dealt with this with polar coordinates, when we write z in terms of r e to the I theta, just to draw a diagram. If z was over here, r was the length and theta was the angle being measured to the x-axis. And therefore the angle was somewhere between minus pi, not touching, so not including minus pi, going all the way around to pi and touching. So the theta is restricted to be in that range. So if z is r e to the I theta, r is e to the log r. So e to the log r times e to the I theta should be, and it is, we get that rule, e to the log r plus I theta. So what we'd like to do is define the logarithm of z to be this number here, the logarithm of r plus I times theta. Notice that you're actually, log of z gives you log of r, but the theta just comes down, which is a bit strange, but you'll get used to it, and it's actually right. So the important thing to remember now is that theta is restricted to be in this range. This is called the principal branch of the logarithm, and this is the one that's implemented in all of the ANSI standard computer languages and in all of the problem-solving environments like MATLAB and Wolfram Alpha and Mathematica and Maple and basically all of them. If you ask for the logarithm of a complex number, it'll give you this one, and it's the imaginary part will be trapped between minus pi and pi up to and including pi. So I remind you that r is the square root of x squared plus y squared, and I remind you that theta is the 2-argument arctangent. So if you say arctan of y comma x in Maple, it will give you the argument. And that's in complex variables text, it's also called the argument of z, and the restriction is this one in most books, but not all. In our book, they use this restriction, and that's the right version. In Copson, it uses this one, it's the right restriction. In RP Boas, it uses this restriction, it's the right one. But other books don't. But all computer languages use this one now. And when you ask for the complex logarithm, you get one number. You don't get an infinite number of answers, you get one answer. Now we have our definition.